Charles wants to purchase a new machine for $69,000, excluding $2,000 of installation costs. The old machine was purchased 8 years ago. It had an expected economic life of 10 years with no salvage value. The old machine has a book value of $5,000, and Charles expects to sell it for that amount. The new machine will decrease operating costs by $12,500 each year of its economic life. The straight-line depreciation method will be used for the new machine for a 6-year period with no salvage value. Now, you can see how I laid out the cash flows down here. Okay, the new machine cost us $69,000. We're expecting to pay another $2,000 for installation cost, but we'll get $5,000 back when we sell the old machine. So the sum of all of that looks like right now, period 0, right? We're going to have a cash outflow of $66,000, and then we've got $12,500 of cash savings for the next 6 years. So if we look at just a single column of cash flow, this is what they are, and these are the periods which they occur. Now, to compute simple payback, you could do this cumulative cash flow approach, where you just calculate the cumulative. We start off with $66,000, and we add to it the $12,500, so now we're only negative $53,500, but that took a year. And then we repeat. We're still negative $41,000 at the end of 2 years, so add another year. And you just keep going through this, right? And eventually you're going to go positive. Okay, so once we're positive, we've got to do a partial year calculation. Here's how you do that. Turn the 3,500 into a positive number and divide the 3,500 by the current year's cash flow. So 3,500 divided by 12,500. And that tells us that we expect only 0.28 of year 6 to be needed to pay us back in terms of simple payback before the future cash flows equal the costs. Now, this does assume that the cash flows occur uniformly over the year. All right, and then what you can do is just sum all of those. I hit the wrong button here. I hit the F2 button. I hit the F1 by mistake. And that gives you 5.28. Now, if the cash flows are all the same, like in this problem, for all the future years, then you can just simply divide the cost by the cash flow. Okay, so here I'm dividing G13 by, 66,000 by 12,500. I am turning the negative into a positive number first. You can see the little negative sign there. Okay, so here's the formulas I've used off to the side, and you should be able to see the reference cells. And then finally, you have to calculate internal rate of return. Now, what is internal rate of return? It is that rate that would force this cash flow stream to equal 0 if we were calculating net present value. So we are essentially calculating net present value using the interest rate required so that net present value is forced to 0. And we do that with internal rate of return. And that's a simple approach. I'll just show you how to do it. You type equal IRR, hit left parenthesis. I like to come up here to the insert function button. I get a pop-up, and you tell it where the values are. They're right here. This column. Okay, and long as those are spaced at consistent time periods, like at the end of every year, and we always assume the cash flows occur at the end of the year. Okay, that's why this cash flow is different from that cash flow. We do that. What do we get? And then it wants a guess. Now, in most instances, you can leave this off. If I have no other basis, I might use 8% or 10%. So here I'll put 10 in, and you'll see the number won't change. 0.037 is the same. So for this illustration, I'm going to leave it off. And that's this problem. Now, I suppose I should I was going to put the formula here, but I think it'd be better if you guys just watch the video and see how the formula is calculated.